Hello, today I'm going to go over graphing exponential growth and carrying capacity. So these are two different things that we're going to graph. And it talks about it here, how exponential growth and carrying capacity are related to ecology, because we're talking about, in this particular case, what populations look like as they get bigger. So as reproduction happens, and how do the populations eventually stabilize? So you got two different things here. First is exponential growth. And a lot of times we use the example of bacteria going through exponential growth. So what that means is like one bacteria becomes 2, and then that doubles to 4, doubles to 8. And it just keeps doubling. Well, in the beginning of that doubling, it stays pretty low. But then all of a sudden, that doubling makes those numbers skyrocket and it just shoots up. But we know that exponential growth can't be sustained. Otherwise, the whole surface of the earth would be completely covered in bacteria. So at some point, something limits this growth. And that's where we get carrying capacity. Carrying capacity is that limit that says, okay, a population's going to grow, even start to grow exponentially, but something's going to slow it down eventually. And it's going to stabilize at a certain point, because you have to remember, everything that's alive is competing for resources. So there's limited food, limited water, limited shelter. There's limited resources, so there has to be competition, which stops this exponential growth. And depending on the environment that we're talking about, they're going to have different carrying capacities based on that environment or that region that you're talking about. So we're going to do some graphing today. I've got two data tables. First down here is for exponential growth, and then the second one is for carrying capacity. Now, this first graph here is where we're doing exponential growth. Okay, and you can pause and look at the axes here that I've put in. The graph down here is going to be exactly the same. So same numbers on the axes, same titles on the axes. It's just we're going to use the carrying capacity data table down here. All right, so if this one is my exponential growth, let's do a couple of these. On day 1, I have a population size of 1. So here is day 1. And for population size, it goes from 0 to 100. So it's really hard to put one population here, but I know it's going to be close to that 0 line. And you'll notice for day 2, it's 2. For day 3, it's 4. These numbers stay pretty small. So for day 2, at 2, there's basically, on this graph, there's really no distinction. So it stays small for a while. I'm going to skip ahead to day 8. and graph the data point for day 8. And that population size is now at 128. So here's day 8, here's 100. So 128 is right about there. But you're gonna go through and you're gonna plot all these points, and it's gonna show you some type of exponential growth. And then down here, you do the same thing, but with carrying capacity, and you'll see that it's gonna look different. Starts off looking similar, but then it changes. All right, I hope this helps. Let me know if there's anything I can answer. Thanks, bye.